Hi, and welcome to Graphing Linear and Nonlinear Functions. This is the only set of notes that we're going to use on Chapter 4, and it's kind of a review of several sections at once. Make sure you set up your notes. This can be in your interactive notebook on page 23. Call it Chapter 4 Graphing and Equations. Our essential question is, how do graphs, patterns, and equations relate? Today is the 20th, but you can write whatever date you are doing this. Pause if you need to, so you can set up your notes. Alright, so I'm going to start off with just a simple pattern. First pattern is 7, 10, 13, 16, 19. And what we want to look for here is the common difference. So the common difference is just if you took any consecutive numbers and you subtract them, what you would get. So common difference. In this case, if you do 10 minus 7, you get 3. So when we're going down the pattern, this pattern is here, we are continuously adding 3. You might be wondering how that helps us. Well, if we also come back here and label, let's fix that. Come back here and label each term. So this is the first term, the second term, third term, fourth term, fifth term, and so forth. What we're doing is we're setting up a chart. Okay, so again we're showing how patterns can relate to charts, in which this is the x value and this is the y value. So we can find an equation for this by looking how each time we add 3, and by design we set this up as each time we add 1, and when you're to find a pattern for this or an equation for this, we can set it up in the general format of y equals blank x plus blank, and we're going to try to fill in those two blanks. This first blank is called the slope. Okay, so the slope is a measure of how much our pattern is changing, and if you look at this, how much is it changing each time? It measures the difference of the y's over the difference of the x's, or 3 over 1, or since we set it up as each time going up as 1, it's simply just whatever that's changing each time. So our slope is 3. That's part of our equation. Y equals 3x plus something. That something stands for the Y-intercept. The Y-intercept is where the line, where this pattern, if it were graphed, would cross the y-axis. And the Y-intercept, in this case, can be found when x equals 0. So here's x right here. We'll use our fancy laser tool. Here's x, and if 7 is the first term, I'm going to go back to 0. So we're taking one step backwards from 1. So if we do that, we're going to continue the pattern, take one step backwards from 7. The number before was added 3 to get 7, so that number must be 4. So our y-intercept is 4. So again, slope, this number, comes from the change that happens in our pattern, plus 3, plus 3, plus 3. That means our slope is 3. And we multiply by x because continuously multiplying or continuously adding something is the same as multiplying by something. And this number here, this y-intercept, is where x equals 0. To find x equals 0, you just step back 1, step back 1. 7 minus 3, the common difference, will give us 4. So if we want to graph that equation, and again the equation is y equals 3x plus 4, we use what we just learned, that this first number here is our slope and this number is our y-intercept, to our advantage on the graph. Now you could do an xy chart, and technically in the slide before you saw all the points of where we can do. So our first point was 1, 7. So we can see if it fits once we do our original graph based on slope and y-intercept. And this is the easiest way to graph, really, once you get the concept down. Alright, so the number we start with is the y-intercept. Because when we're graphing, this is our x-axis, this is our y. So we're going to see where does that line cross the y-axis, and it says it's at 4, so I'm going to start here at 0, right in the middle. Okay, see me? And we're going to go up 1, 2, 3, 4, right there. That's our y-intercept. So I'm going to put a point there. Not the prettiest point, but it's there. Alright, so that's our y-intercept of 4. We start there, start with the y-intercept, and put a point. Now from there we can ignore the rest of the 4. That doesn't tell us anything else. We look to our second number, and again this is the slope. Slope can be expressed as a measure of rise over run. What I mean by that, rise is how much you go up or down, run is how much you go to the side. Okay, so if we're saying that our slope is rise over run, that means our slope is 3. If you don't have any fraction, you can add a 1 there. So that means we're going to go up 3 and over 1. So using the pointer, we have to go back to that y-intercept. There's a reason we put that there, because that's where we start, and we're going to go from here, we're going to go up 1, 2, 3, and over 1. Alright, I'm going to put that with our point now. Up 1, 2, 3, over 1. There's where our point would go. It's a good idea to repeat that and go again. Go up 1, 2, 3, over 1. We're almost off the graph. That's okay. I'm going to add another point, and that should be straight enough to make a line. So our last step is just to connect the points, and we have our line. So this is the graph of y equals 3x plus 4. Let's try another one. This is an example of a nonlinear. The only reason I know that is because I did this problem ahead of time. You may not have known that, but we do need to look at nonlinear. We know the last one was linear because when we graphed it, it made the shape of a line. So I'm going to look at the number of terms we have here. This is the first term, second term, third term, fourth term, fifth term. Again, setting up our chart here. And I'm trying to find a common difference, so the difference here would be plus 3, then this is, oh wait a second, plus 5, and then plus 7. Hey, wait a second. This is not linear, it's not going up the same amount each time. And you're right. That's why we don't set it up with a y equals blank x plus blank. The actual equation for this, just because I know if you look at how do you get from the first term to the second term, is y equals x squared, because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So that's an equation for this pattern. What's more important is the graph of this pattern. So again, when we're looking at y is equal to x squared. So we start with our points. We would go over 1 and up 1, point. We would go over 2 and up 1, 2, 3, 4. And we can go over 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Just barely still on our graph. I'm going to leave it at that. If you had checked the other points, like the y-intercept in this case is 0, because 0 squared will give you 0. And if we tried some points on the negative side just to test them out, you would find a symmetry line. Not that you need to worry about this, but I just really need you to make sure that you notice that, hey, this doesn't make a line. And in fact, that makes a curve, which makes it nonlinear because the graph of it is not a line. Time for a learning check. So go back and look at your notes. What we've done so far is we had a pattern, and from that pattern we learned to write an equation. The equation can be written in the format y equals blank x plus blank, in which the first line, the first blank, is the slope, second blank is the y-intercept. Slope is the change each time in the pattern. The y-intercept is where you started, or when x equals 0, the number before the term before the first term. We use that information to graph, starting with the y-intercept. That's where we graphed, and then we use the slope to rise and run to go to the next point. So go back, look at your notes, make sure you have that. Meantime, I'm going to be looking at this chubby little kitty. Like, you can't even see its feet. That's how fat it is. Alright, so what we're going to do next is just really focus on how we can go from this equation, or any equation,